Okay, so I will start my system design practice from now. Okay, so this is after a long time. I mean, after a few months. So I don't remember how I should, structure the design. Yeah, I mean, structured conversations. I have to remember. And yeah, I have to remember the structure when I'm talking. So probably this wouldn't go smoothly. And I don't know how much time it will take, but let me go with that because I'd like to remind myself while I'm talking and also recording myself is quite a good practice. Okay, so that being said, I will start my practice. So today the topic I'm prepared is okay, so design hotel booking system. So this is my today's topic. Hotel booking system. Yeah. Okay. So that being said, yep. So let me start with functional requirements. So when I think of the hotel booking system, yeah, what I can do probably is okay. Let me think with writing the UI because it is the most easy to image the website. Okay, so okay. The hotel website would be something like this. So probably I would search maybe some keywords, but basically with place and dates. Yeah, yeah, place and also date and price. Yeah, probably I will be searching with this information. And then when I click the search button, there would be some, oh, and also the number of people. Yeah. And when I click the button, search button, there would be listed some available hotel informations. So this would be some okay. This would be something like yeah, maybe with these prices, date, price, number of people information. So this is the basic I just UI, I mean the home page of the website. And also after selecting the button, I can do the reservation. So probably I will input the address, name, and maybe the number of people, and also obviously I need to input credit card info or something. I mean payment is the key, one of the key features I can say. Yeah, maybe this can be online payment, credit card, or maybe pay later as a hotel. Yeah, and something like that. Then when the reservation and payment succeeds, I can see the history of my reservations. Yeah. Okay, so these are the UIs I come up with. So yeah, let me clarify the functional requirement with this. Okay. So probably what I can say is the first functional requirement is user can book search hotel rooms. with conditions. Yeah. And also user can book a hotel room, the rooms, and including payment. And also user can check the history of the reservations. Yeah. Also, yeah. User can search. Yeah. Oh, and obviously, so what I forget to say is from here, uh, the, I mean, user can see the detail of the hotel room, I should say. Yeah, so obviously, yeah, user will check the details of the hotel room, and then if he prefers it, he book it. So this is also another function requirement. Okay. Yep. Oh, and yeah. Also, this is the basic flow of the reservation, but also what I can say is probably user can, sign in feature, and also, yeah, update user info, because, yeah, user wouldn't like to, input their use addresses or emails again and again each time he reserves the hotel. Yep. The same for the payment info. Okay, so this is the function requirements I came up with. Yeah. So I talked about it from the user's perspective, but also I think from the, yeah. So probably there is another user in this system for this system, which is the hotel owners. So probably hotel owners would like to register the hotels. Yeah. Register his hotel rooms. Hmm. And yeah, probably vacancies. And also I can say maybe the hotel should be, yeah, I mean, reserved by many websites, many hotel booking websites. So yeah, maybe there needs a system that when the vacancy of the hotel room is updated, it is it should be updated to this hotel booking system. So maybe it's another thing I have to take care. But yeah, okay, this is the specification, and probably I will be focusing on the mm, 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 mm. Yeah, in this um practice, I will be focusing on the um number of bookings. So I will be, I will make sure that how the booking logic, I should say business logic should work as expected. Yeah. So I will be focusing on that. Yeah. So probably I wouldn't focus so much on sign up, sign in, user info, payment info. Yeah. I will focus on this. Okay. Yep. And maybe this one. Yeah. I wouldn't focus on the APIs for each endpoint, but I will be focusing on the tables and how I can make sure that, for example, um, the same room wouldn't be booked by multiple people or something like that. Yeah. Okay. So before going to the non-functional requirement, I'll make sure that the kind of logic, internal logic of these reservations. So I will go with the, specifications that there maybe one or more types of rooms in each hotel. And yeah, user can obviously reserve multiple rooms. Yeah. Okay. And yeah, each. So also I will make sure that user doesn't specify the room number, but only, yeah, room type. Okay, this is another requirement I've just come up with. So yeah, it doesn't happen that user, yeah, because my understanding is that there are some people who cancel the reservation. So some hotel booking, yeah, some hotels um allows use, number of users which are more than the capacity to reserve the rooms. And finally, that's the systems some of the hotels take. And if they say the number we cancel the rooms that were is not enough, so yeah, I mean the hotel gives a kind of compensation for that, and some users cannot use the hotel, so maybe those users uses another hotel near that hotel. Yeah, but in my system, I wouldn't arouse that. So if the user makes a reservation, or I should say, the number of users who reserve the one hotel type never exceeds the actual capacity of, yeah, the hotel type, room type. I mean, number of hotel room, number of rooms of that type. Yeah, yeah. Okay, so yeah, okay. So let me go to the non-function requirements. So design of hotel rooms. Okay. Okay, so here, yeah, let me think. So probably the one of the non-functional requirement which comes to my mind is the consistency. So no double booking should be allowed. Yeah. So say one room type capacity is 5, and if the maybe 10 users try to reserve the room at the same time, it wouldn't be allowed, obviously. Only 5 people should be allowed. Yeah. Up to 5 people should be allowed. Okay. And also, so yeah. So from this, I come up with high durability. Yeah, so data, reservation data or payment history data are quite important, and losing them would be the big loss of the, yeah, big loss for the business. So it should be, yeah, avoided as much as possible. And also scalability. So I will have this discussion later. Yeah. But probably this service should be really heavy. Yeah. Because yeah, many people yeah looks around the hotel information, their pages, then finally decide one room, one hotel, and at that point, right operation occurs on the system. So probably this will be really heavy, and yeah, but I think not so extreme. Yeah. Okay. I will talk about this, discuss about this later. And for latency, it should be say, yeah, hopefully it should be 100 millisecond or something. This is the, basic, yeah, acceptant, I mean, ac acceptable latency, yeah, typically. And also for security perspective, yeah, this is, yeah, so correct. Oaths and also probably, yeah, defense from DDoS attack, yeah, or something. And also maybe some rate limit is, yeah, maybe this would be useful because some people maybe would like to do the scraping the website with collecting the information. Yeah. So if it isn't acceptable, yeah, we should do the rate limiting system or something. Yeah. Okay. So this is a non-functional requirement. So from here, I will talk about the data. Yeah. So okay, so yeah, I will talk about the data. So yeah, okay. So basically, yeah, this application obviously should have backend and frontend, and frontend can be say mobile apps or web, yeah, desktop app, or I mean, yeah, website, web application, or something like that. But I will be focusing on the backend in this conversation. So I will do the data, and first thing I'd like to do is the data size estimation. Yeah. So the data I have to store is the user's data and hotel. Yeah. hotel types data, or I should say hotel inventories. And also, yeah, so, oh, okay. Hotel inventory. So what I mean by hotel inventory is hotel, yeah, each records. So, I mean, each record signifies the hotel, say hotel ID and room type ID. Yeah. And also say, okay, so number of available rooms. Yeah, and so on. So maybe I need some price or something. So this is yeah, their inventories information. So probably this number of available rooms column is quite important. Yeah. Okay. And also I should have the reservations record. Okay. And also, yeah, shape to neck. So from this, okay, yeah, is that it? And also, when I think of this, so this hotel inventories record should have the, I mean, so wait, so what I mean by, oh, yeah, pictures of the hotels or hotel rooms. So probably this is also important. So maybe I can do it in this way. So maybe I can say hotel types, yeah. And this should have hotel information. Maybe I can use another table, hotel, and I can have hotel ID here. Let me go with there. Let me go with the idea that each hotel room type have one record, including the hotel. Yeah, hotel information itself. Okay, so this is hotel type, price, and hotel type, price, and yeah. Also, what is important is images. Yeah, then here this can have their room types. So this can reference with this hotel room type ID or something, I can reference to the detail of their room type. Okay. Okay, so that being said, these are the informations I need in this table. Yeah. So from here, so I will do the estimation. So I will assume that this website is a worldwide one. Yeah, or maybe the biggest one in the country. So I will assume that the number of users is 10 million. Okay. So if there are 10 million users, so I assume that each user has the information, which is say 101 kilobyte. Yeah, including their address and payment, if yeah, payment information or something, and name or email address or some, session information, no session, but kind of authentication information. So assuming that this should be 10 meg, so 10 gigabyte, yeah. Okay. And for the pair room types, I will assume that it's difficult to, it's challenging to estimate how many hotels there are. So, but let me assume that there are, say, 1 million hotels in this room. No, yeah. So in Japan, let me think. So 50. Yeah, okay. I think 100K hotels is, yeah, the sensible number. So I will go with this. And assuming there are 5 types is hotel. Yeah. So I will go with this. And I will also, again, I will assume there are 1 kilobyte. Yeah. Maybe 100 byte to 100 kilobyte data for each type, their type. So with this estimation, I can say it should be, let me assume that there are 200. Yeah. Sorry, yeah, I will go with 100. Okay, so with that estimation, it should have 500 megabyte. Yeah, data size. Oh, but images, this is quite big. So and for images, let me assume that, so I said there are 100K times 5 room types. And I will assume that for each room, there are 5 pictures. Let me do it with 10 pictures. And I will assume that each picture is 100 megabyte. Yeah, in this way, let me assume. So 100K times 10 is 1 mega. And 1 mega times 100 mega is gigatera. So 100 terabyte. Yeah. Times 5 is 500 terabyte. Yeah. Okay. Let me confirm it again. So, okay, megabyte, kilo, this becomes gigabyte, then 110, this becomes terabyte. Oh, yeah. So remaining is 105, so it should be 500 terabyte. Makes sense? Okay. Yeah. Okay. So wait a minute. So yep. I think I'm not pretty sure this is correct. 100 kilobyte. Yeah, and this is correct. Okay. So, okay, so hotel inventory. So this is a tricky part because hotel inventory is, as time goes by, okay, so basically hotel inventory record should be created every day. So yeah, I forget this. Yeah, so okay, I will assume how many dates I should store the record. The let me assume that I will record, say, 10 years. Yeah. And after that, probably the date should go to, say, the cold storage of say S3. I mean, yeah, cold storage of storage, yeah, system, you know, object storage. But for now, I will, yeah, go with this. So 10 years times 306 days. So this is the number of days. You can see just say, yeah. And then, so hotel room type. So hotel room type, there should be 100K times 5 hotel types. So then, yeah. Then I will assume that each row has 100 byte. So let me assume this. So 10 times 100 byte, it becomes 1K. And 1K times K becomes megabyte. So now it's 1 megabyte and 105, so 500 megabyte. So this is around, so I will assume that this 365 should be almost 400. So this should be gigabyte, yeah, 200 gigabyte. Okay. And lastly, for reservations. So also I will book 100 years of data. Yeah, because the thing is the reservation record should be viewable in each user's reservation history page. And it makes sense that, say, you can look back around 10 years of records in the UI. So it is a sensible specification, I think. So let me go with this. So let me assume how many reservations there are. So the number of hotel is 100K, 500K. Okay, so let's let me assume that 100K is the hotel room, hotel type count, and I assume that the 50% of the room is reserved. And on average, yeah, on average, 2 people reserve the room as one reservation. So in this way, I can assume the number of the reservation in each day is, yeah, 125K. Yeah. Then, yeah. I will assume that each record has 100 bytes. Okay, so with this estimation, I can say 1 kilobyte, 1 gigabyte. So I will assume that this is almost 400. Yeah, 50 kilobyte of records. Oh, wait, this is quite small. What happened to this? Let me think. Oh, I can just say, comparing this with hotel inventories records, this is 1 out of 4. So I can say it should be 50 gigabyte. Okay, so I finished the data size estimations. So from here, let me think the data model and also which data storage I should use. Okay, so okay, so data. Yeah. Okay, so for users table, I think I can use the relational database. Yeah. Because yeah. So basically, okay. Yeah. This is because users information can be joined with hotel room types or especially reservations. So okay, let me say users information, also reservations tables, also hotel room types for the same for it. These can use relational database table. Yeah, the reason why I think this is quite useful is, oh, and also hotel room types. Okay, terrain boundaries. Oh, I mean, so I'd say almost all of them I can use relational database tables. And for the hotel room images, I would use, I mean, object storage, like S3. Yeah, because, yeah, for users and reservations and some other relational database tables, the justification of this is that the first thing is that I'd like to merge, I mean, joins the tables. So as I said, for each user, I'd like to get the list of reservations in the past. So relational database is quite performant for this usage. This is one thing. And also the other reason is the transaction. So as I've written in the non-function requirements section, so consistency to avoid double booking is one of the biggest requirement in this system. So for that purpose, relational database you works quite well because the relational database is quite strong, has a quite strong and powerful, you know, transaction system, so I can use it. I can use the native transaction system mechanism in relational database tables. Yeah, okay. So I mean, I can lock the table, especially the hotel inventories. This one, this hotel inventories tables available rooms column. This should be definitely locked when the reservation is going on. So yeah, that's the thing. Okay, so yeah, I actually talked about the data model and table schema. Yeah, I talked about the overview of that when doing the data size estimation. So the I did it. Okay. So okay. So now I will quickly tell you about the API endpoint which I should create for the backend of this system. So I will pick up some of the most important ones. So the first thing is the this usage function requirement one, list search result. So this should be get endpoint. I don't know. This is the host name and I will insert the path. Then I will specify the condition with say parameters, like date is, you know, like this. Date from and probably I can specify the upper price and lower price and number of people for something like that as the query parameters. Okay. The second thing is what is it? So yeah, the detail of the room. Oh, I mean, I will use defining the REST API here. Yeah. So get room details. So this can be done like their rooms and their ID like this. Yeah. And also one more thing I'd like to, define quickly, show you quickly is, this endpoint. So bookings of their room. So for this endpoint, it should be post because post is the endpoint, I mean, HTTP method which defines the new record. And definitely this reservation is a new kind of new record. So So yeah, and probably, as the body requires JSON, so it should have, room ID and date or something like that. Yeah, or maybe hotel room type ID can be used instead, because each hotel room type has the hotel type price, hotel and type, and also date. No, sorry, hotel inventory. Yeah. Probably I can use hotel inventory ID in the JSON. So this can be, used as, yeah, this can, identify the room to be reserved and the date. Okay. Okay, so this is API design. So now I will work on showing you the system architecture of this system. Okay. So yeah, I will omit the hotel owner's feature. I will focus on the user's feature. So this is the user. Yeah. And probably there should be the application server. Yeah, which has the business project. Also, there should be the database. So as I said, I should use relational database, and there are some tables inside of it. So when the user makes a request, yeah, it should make the request goes to the application server and it fetches some data from RDB, or sometimes from the S3, object storage, and then it returns it. Okay. So this is kind of a three-layered architecture, But what I can do from here is probably for the scalability, I will put the old load balancer here, and load balancer, dispatches the request to, each web server, like Apache or something. And what I can say is the static data, static, website, say HTML or something like that can be written from here. Yeah, so static content should be here, and dynamic content is created here. And for that, it fetches data from our DB. Okay. Yeah, so this is the basic design, but I should think of the scalability and performance more. Yeah, also as I said, it should be, S3 something. Yeah. So what I can do is, the first thing is, probably what I can do is for the availability, I will put the RDB to the, yeah, multiple regions. So however, in this system, the transaction is important. So there should be only one, um, write replica because I shouldn't do the, I'm I don't want to do the, um multi-read multi-read rep multi-read structure or yeah, because I'd like to provide the quite strong consistency. So the write operation should be here. So I mean, so recoding when the record is written, asynchronous result is, updated to the relational database. I mean, replicas, read replicas. Yeah. And what I'm thinking is, so I will put this, yeah, this in multiple regions. So probably, okay, if this is a worldwide, yeah, website, it should have this multiple, um, yeah, multiple architecture in the backend. Yeah, in this way. So, okay. So this is one thing. So here I've added replica. And also the next thing I can do is for the performance improvement, I can put the content delivery network. So, okay. Probably what I can do is put the CDN, and for the images, users makes request. Oh, let me, probably what I can do is users should request from the images of the hotels from S3. However, I can put content delivery network in front of that. So this can cache the data. Yeah, inside of it. So yeah, this is quite useful, I think. I mean, this makes the performance, this improves the performance. And also, one thing I can say is, obviously, depending on the location of the user, the hotel they're interested in differs. So if the user is in the Japan, probably most of the users interested in the national, I mean, hotels in Japan. Yeah, obviously there are some users who would like to travel to the US, but the number of them is less than the domestic traveling people numbers. So yeah, this makes sense to, I mean, the content delivery network is basically the user's request go to the, closest edge place, edge location, close to the user. So yeah, I think this makes sense to cache the data. Yeah, I mean, the cache miss rate can be reduced in this way. Okay. And also for, yeah, and also for the, I'm thinking of using the caches. Maybe there's some data that can be cached. Hotel inventory can be cached because available rooms should be up to date. About hotel room types, this can be cached. So maybe I can use put the Redis. Oh, I mean Redis or some other in-memory database to, yeah, I mean put cache the hotel inventories recode. This is a performance improvement. And what can I do? Oh, and also for the scalability, what I can do is introducing the auto scaling group. Yeah, kind of auto scaling group. So in the, yeah, in what we call in AWS is auto scaling group or something. So yes, hardware layers should be auto scale. Yeah. Okay. And what should I do next? So yeah, okay. So I think this is quite reasonable. Yeah, architecture. Okay. So let me add one this customer thing in then. Yeah. Oh, so okay. Yeah. So in the non-functional requirement, I talked about the consistency. So yeah, because I used RVB and there is only one right replica. Yeah. So consistency, strong consistency can be guaranteed. And also for high durability, yeah, relational database data is replicated. So yeah, this guarantees the high durability of the records. And for scalability, yeah, I talked about the auto scaling and yeah, basically load balancer scales automatically. Yeah, in AWS, actually, a load balancer is actually a collection of EC2 instances. So yeah, okay, so the scales and for Redis is okay. Oh, I mean, about the latency discussion, I talked about content delivery network and also Redis, which is a caching layer. So this, yeah, speeds up, reduces the latency. And yeah, maybe I can use the, probably I can use the indexing in relational database tables. Yeah, which is on the schema definition discussion. Yeah. And for security, yeah, I omitted this in this discussion. But for rate limiting, AWS has a good kind of rate limiting system in load balancer layer, so maybe I can use it if this is in AWS. Okay, and quickly I will talk about the final thing, which is the details of transaction. So yeah, so okay, so basically, so this double booking program is called the lost update program in relational database. So I will talk about it. Double booking. So basically the problem here is that if there are two clients of the database tables, so I mean, yeah, and also I can say think of the two users who write the reserves the book makes the reservation for the one hotel type. And if the current number of availability is 2, and okay, let me say 1, and if there is user 1 who reads this recode and then update it with 0 because he reserves it. However, if the other user reads the recode after, before he overrides the recode with 0, so this user 2 reads the number of availabilities to be 1 also. Then if the user 1 updates then what happens is that user 1 updates the recode with availability 0, then user 2 also updates the availability number with 0. So in this way, even though the availability was only 1, user 1 and user 2, both of them could, reserve the room. So this is obviously double booking problem. Yeah. So there are two ways to, get over this problem in relational database. The first solution is use direct or update statement. So this is basically the, low level locking kind of. So when user 1 selects reads the column of the hotel he is interested in, which has availability 1 column. When user 1 reads the recode, it also locks that row. So user 2 cannot update the row until, user 1 makes a commitment, makes a commitment to the table. So this is one of the solution I can use. And the solution 2 I can use is so select and set segment. So okay, so I've written solution 2. This is the second solution I can use. So I can use the select set statement. So in this way, so reading the record and also updating the record, reading and updating the row, these operations are done in an atomic way. So in this way, the loss update problem can be avoided. Yeah. Okay. So okay, so this is, I've talked about the details of the, how to avoid double booking problem, loss update problem in the end, because this is the most, I think, important part in this system design. So let's call it a day. So thank you so much. See you soon. Bye.